Hi everyone. Today we're going to talk about probability events and some more vocabulary related to probability. So let's start with rolling a fair six-sided cube. So it's got the numbers 1 through 6 on it. Let E be the event. We roll an even number, so 2, 4, 6, and T represent roll a 3 or roll a 5. So last semester we talked about the union. So if I roll a 3 or a 5, or I roll an even number. So even number or 3 or 5. So as long as one of these events happens, it's considered a success. So the probability of E or T, at least one of those happening, is 5 out of 6. Okay, any 2 is the only failure here. Now, the intersection is the word and. So what's the probability I roll an even number that is also and a 3 or a 5? Well, it's impossible. So the probability is 0. There's no even numbers that are also 3 and 5. 3 and 5 are odd. Even numbers are even. So no overlap, no intersection. And then the last deals with the complement. So the probability that you do not roll an even number. So in this case, the opposite of even is odd. I want us to get in the habit of saying not even, because sometimes there's multiple possibilities, but this is saying probability of not even is 1/2. Okay, 3 out of the 6 opportunities. So let's talk about mutually exclusive events and independent events today. Mutually exclusive are events that cannot happen at the same time. For example, roll an even number and roll a 3 or a 5. There is no intersection, there's no overlap. So if I asked you the probability of at least one of them happening, we can just add up the two probabilities. And if I asked you what's the intersection, there is no intersection. They cannot happen at the same time. So that's how you know if events are mutually exclusive, if they cannot happen at the same time. And then the complement is saying the not event. So everything else except that event. So if we think about the last example where the event was roll a 3 or a 5, the complement of that is roll anything but a 3 or a 5. So a 1, a 2, a 4, or a 6. So all of the other possibilities. Now, non-mutually exclusive events means there is overlap. So to find the probability of at least one thing happening, we can add up all of A to the probability of all of B, but then we got to subtract what the overlap is because we don't want to double count it. So the intersection is not going to be 0. There is going to be some overlap. So let's say I roll, and what's the probability of rolling an even number that is also less than 4? So even and less than 4 is 1/6 because 2 is even and less than 4. Now, what's the probability that I roll even or less than 4? Well, there's a half chance that I roll an even. There's also a half chance I roll 1, 2, or 3, which is less than 4. But then I have to subtract the overlap because this one number, number 2, is in both of these categories. I don't want to count it twice, so I subtract that. So 1/2 plus 1/2 minus 1/6 is 5/6. The probability of even or less than 4, there's 5 out of the 6 numbers that happen for that. So mutually exclusive has no overlap. Non-mutually exclusive will have overlap in the same event, the same trial. Now, independent events are if I'm going to do 2 or more events consecutively, does the first event affect the outcome of the second event? So if I'm going to roll a die and I'm going to flip a coin, it doesn't matter what number comes up on the die. The coin has no memory, so the coin is going to be heads or tails randomly. So to find the total probability of A happening and then B happening, we just multiply the probability of A times the probability of B. So if I want to roll 4 and then flip a tails, okay, 1/6 probability I roll 4, half probability I flip a tails, 1/12 probability I roll 4 and then flip a tails. There's 12 total outcomes that could happen. Only one out of those 12 has the result of 4, then a tails. So now let's check some examples where there is independence and some not independence. So if I randomly select a marble and replace it, then the second marble is going to be independent because then I have the original bag. So this second marble being green, if I put all the marbles back in, it's still going to be 12 out of 20 because I have 20 marbles still in my bag and 12 I know are green. Now if I take a marble out, then my probabilities are going to change depending on did I take out a green marble or a violet marble. So with replacement is going to be independent events because each one has its own independent probability of happening. We're not changing probabilities. But if I start removing things or changing the odds, then that's dependent probabilities. So the last example we'll look at, okay, orange and purple and other balls in a box. There's 100 of them. So the probability of purple or orange can't be both. So I just add up 30 and 10 and get 40 out of 100 are purple or orange. Now, not purple and not orange is the remaining 60 balls. So 60 out of 100 is 3/5. And then once again, since these are mutually exclusive, it can't be purple and orange. So if they're mutually exclusive, the probability of it both happening is 0. Same thing with dice. Okay, probability of rolling an even number that is not a 6. If it's a sample space, we can count up the probabilities or do even and not 6. What's in the middle? What's the intersection? Okay, and then independent events, if they're two independent dice, we could take each probability and multiply them. So we will determine whether it's mutually exclusive or independent, and then follow the rules of probability as we go throughout this chapter.